Hi, my name's James Carroll. I'm a game developer out of Cary, North Carolina. I'm founder and lead developer at N-Dimensional Games, LLC. We have a game on the Google Play Store called Fall Down Mayday Device and are currently working on a title called REM. But enough about me. Let's get into our project outline. So this project is making an item collection game and integrating mobile ads through AdMob. AdMob, of course, is Google's advertising platform, and we're going to import that API into Unity and work with it. So the way we're going to do that, this is going to be a really fun project. We're going to create a simple prototype for a rolling ball game called Crazy Tilt. We're going to set it up to respond to gyroscopic input from your phone and roll around the board based on that. In part 1-2, we're going to add a little bit more complexity. We're going to create 2 levels with switches and doors, as well as a level progression system. And then once we have those 2 levels set up, we'll add a menu to our game. In part 2.1, we're going to add the AdMob API to Unity and initialize our ads, and then create our placements through the website. So we'll get all of our keys and we'll set those up. And in part 2, finally, we're going to implement our ads into our game through code. We're going to call our banner ad on the main menu, we're going to call our interstitial ads between levels, and we're going to call a rewarded ad that will add a special effect on your ball and give you a ×2 bonus for watching that ad on the main menu. What are the requirements? You should really just have an Android phone and a cord and some Unity experience. No special art skills needed. We're just going to be using the basic primitives in Unity. And this is basically for anybody who wants to learn how to create an item collection game, how to get their feet wet in mobile development, and also work on integrating AdMob into their own title. And as a bonus, learn how to do tilt input for a game like this. So it's going to be a lot of fun. I had a lot of fun working on it. I sincerely hope you enjoy it. And if you do decide to continue watching, I will see you in the project series. Hello, welcome to creating an item collection game and integrating mobile ads with AdMob. Today I'm just going to be opening Unity 2019.1.1F1 through my Unity hub. I'm going to create a new game, or a new project. We're going to call it Crazy Tilt. Let me select my version. There we go. And make sure I have the correct directory. Cool. Okay, so I'll create the project and wait for that to load up. And while that loads up, I'll give you a brief overview of what we're going to do today. In this part, particularly, we're just going to create the framework for our game. We're going to set up the gyroscopic script. So what you're going to need is you're going to need a modern mobile phone and also a cable to hook it up to the computer. I'm actually going to go ahead and do that now. And you will also have to have downloaded the Unity Remote 5 app, which you can find on Google Play. I'll show you that now. Let me just pull up a window. Unity Remote 5 on Google Play, right here. Basically, all you do is you download this app, you run it, and when this app is running on your phone, we can configure the Unity editor to play on the phone remotely. It is worth noting that there will be a little bit of lag over the cable connection, but when the game is actually built, it's going to run a lot smoother. So the first thing I'm going to do is I'm going to make this an Android project. So I'm going to go into Build Settings, File, Build Settings, go to Android, and then click Switch Platform. And then we wait for the default assets to be converted to Android, and then we're good to go. Let's go to Player Settings, and then go to Editor, Device at the top for Unity Remote. Say any Android device. Okay. I'm going to give this a quick test. I'm going to press play in the editor, and it should show up on my phone. There we go, we've got the scene. Excellent. Okay, so the next thing we need to do is change our dimensions to 16 by 9. So it's going to be a mobile setup. And then we'll start creating our platform. First thing I'm going to do is create an empty game object. Call this platform. And then under this, I'm going to create a cube. So just by selecting the platform, right-clicking, create cube. We're going to call this ground. I'm going to set the X and Z scale to 8. And now we can move our camera around to kind of figure out what kind of angle we want. I'm going to move the camera up in the Y direction because Unity is Y up. 10 units. And then rotate 45 degrees in the X. Next thing I'm going to do is I'm going to take our ground plane and actually, let's make it a little bit thinner, maybe 0.5. Create a new folder. We're going to call this scripts. Create another folder. Call this materials. Create another folder. Oops, sorry, don't show it in Explorer. Create another folder, call it prefabs. Now, in the materials section, right click, create, go to material. We're going to call this ground mat. That's just going to be our naming convention, just use mat at the end of everything. So go with our standard shader, change our albedo to a dark gray, and just leave the default metallic and smoothness settings the way they are. Drag and drop ground mat onto the platform ground. And now you can see this material is applied. Awesome. We need a little more contrast from this skybox. So one thing we can do is actually increase the metallic value. Maybe make it 0.35. Just to let it stand out a bit more. Okay, so from there we're going to duplicate this. I'm going to call this wall. Change our scale to 0.5 width. And then 1 for height. Now in order to get this exact, I'm actually going to expand this just a little bit. In order to get this exact, we're going to hover over one of the corners, hold V, and you'll see the widget snaps to vertices on the mesh. Click and drag, and then drag to the corner that you want to snap it to. You want to snap it to this inside corner over here, which is great. Now let's duplicate this again. Hold V, drag this over to the opposite side, let it snap. Great. Okay, so make sure you have your tool handle position up here set to center, not pivot. Select both walls. Press E to go into rotation, Control D to duplicate, and then click the yellow axis and start dragging, but hold Control to do measured rotation. Alright, now we have our dimensions. Next thing we need to do, the next thing we need to do is make this a While we're at it, let's add the player character. So let's add an empty. Call it player ball. Or, yeah, player ball's fine. Then right click, add, zero out the position first. And rotation if you have any. So it's 0, 0, 0, 0, 0, 0, 1, 1, 1. Now create a sphere. Scale the player ball by let's say, let's try 0.5 at first and move it up. So it's scaled in half in all three axes. Excellent. Now what we're going to have to do is go to this sphere. It's got the sphere collider, so let's add our rigid body to it. Add component, rigid body. And we're going to use gravity. We're going to set the mass to something like 10. And then we're going to set our angular drag to 0 because we want it to really roll around. And our collision detection should be continuous dynamic. Alright, we're almost done. We do need to create a player material that contrasts our floor. So go to Material, Player Mat. We're going to make this very metallic, very smooth, and we'll change the color to something like a blue marble. We'll drag our player mat onto the sphere, and now you'll see the skybox is reflected on it. Okay, sweet, that should be all we have to do for that. Now for the platform, we're going to add a script. So let's go into scripts, right click, create C# script, call this, let's see, gyro controller. This is where we're going to do our programming for our gyroscopic input. I'm going to go to our platform master game object, the parent, and then drag, left click and drag the script onto the platform object. Then go to overrides and apply all. We also want to do the same thing for the player ball, and so in terms of making it prefab. So I'm actually going to zero out its position so that if we do end up spawning this in the level, it will always spawn relative to 0, 0, 0. Drag and drop the player ball into prefabs, and we should be good to go. Let's take the existing instance in the scene and move it up so that it is above our platform here. We got a little shadow forming. Okay, and if you're wondering how I'm flying around, I'm just right clicking and I'm using WASD and E to go up and Q to go down. Okay, from here, normally we would put a script on the player ball to kind of control it, but we're using the environment to control the ball. So let's go to our platform and let's start writing this script. I have gone ahead and done some experimentation beforehand, so this is going to go really smoothly. Wait for Visual Studio to load up. Alright. I had Visual Assist at one point. Now it's bugging me about it. Okay. Should be loaded up. Let's clear start and update. Get rid of that. And now let's do private void of awake. Then say if, oh, I'm sorry. We do need to add a boolean at the top. Let's add some variables up here. We need a gyroscope, gyro, we need a quaternion, which is a 4-component vector that's used for rotation. So we're going to call this real world rotation. And we're going to use vector 3, new rotation, public, quaternion, base rotation to multiply by, equals new quaternion 0, 0, 1, 0. And then we'll have a boolean. Bool gyro active. This is going to tell us whether the gyroscope is active. So at the beginning, we check if gyro active, then return, and then check to see if the system actually supports a gyroscope. System info.supports gyroscope. Then we will assign our variable, our gyroscope variable, the input. So gyro is assigned the value of input.gyro. gyro.enabled. So if it is enabled, oh, sorry, we set it equal to true. We set enabled to true, and then take gyro active, our boolean up there, and set it equal to our enabled status. Else we're going to throw an error in the console, else debug.log gyroscope is not supported on this device. Cool. Now let's go into update, void update. If gyro active real world rotation is equal to our gyro's attitude, then we'll say new rotation is new vector 3, and we're going to do some axis conversions here because I believe the gyro attitude is actually getting X, Y, Z, Z up input, where Unity is Y up. So we have to kind of flip around the signs in order to get a desired result. So you do real world rotation dot Euler angles. To access its Euler angles, get the X component, add 180 degrees to that, comma, our second component is going to be 0 for Y, and then we're going to say negative real world rotation dot Euler angles dot Y. We're going to feed the Y into the Z. And then we're going to apply this new rotation by going transform dot local rotation to assign the value of quaternion dot Euler new rotation times our base rotation. Okay. And now that that's done, let's save it and let's give it a shot. So if I press play, it should show up in our Unity. Yep. Now here's the problem. It is rotating exactly how I'm rotating it here. Let me show you. So left, right, forward, backward. Yeah, that's great. We have no lid on our level, so our ball is just going to go flying off into space. And we also have no constraints, but I'm okay with that because we can work with these settings to make our game. Let's take our main camera real quick. It is a little close to the board, if you ask me. And let's press X to switch to local transforms and grab that Z and just move it back just a little bit. Another thing we could do is actually change our field of view so that it is larger. We'll have to go to something like 34 or 35 millimeters for field of view, and we'll back it up just a little bit. This will make it appear wider, like the playing board is actually larger than it actually is. I think that's around about where we want it, so we can see where the ball is going and how we want to do this. So let's mess with our ground material a little. I think it's a little light. Make it a little darker. Yeah, that works. Cool. So we have our rotating platform. We need an item to collect and a way for those items to spawn in, interestingly enough. And then we also need to add some walls to our first level here. But this is going to be our template, and then we're going to override our template later on. So let's create an empty, we'll call it collectible. And then we're going to take this collectible and add, let's see, we're going to add a script called rotate. We actually have to create it. This will be a simple rotator script. And we're also going to zero out our position. Now the interesting thing is that we can tilt the board. So our collectible is going to be rotating along a local axis, and then we're also going to be translating the collectible as a child of the platform. So let's go into our rotation script, and we're just going to create a simple float speed, and then in update, let's make it fixed update. And actually this update loop, well, might be better suited for fixed update as well, since it's interacting with physics objects. Let's try it. One thing I worry about with this system is the ball actually clipping through the board. But let's make this fixed update, save it, go to rotate, save it. And now we'll do transform dot, what was it? No. Game object dot transform dot rotate. It's a function. Okay. And then we get our angle axes, our angle. Alright. There's 6 overloads. Okay, so angle is going to be vector3.up. Sorry, that's going to be our axis. We're going to be rotating around the up axis. And then we're going to give it an angle we'll call it speed, which will be kind of like, let's do speed times time dot delta time. Okay, and this will be kind of like rotations per second. And we'll make this public. Let's do RPS. Let's call it RPS, rotations per second, so that we know later on. I'm going to space this out so it's easier to read. Just a habit. Alright, so now that this is public, we should be able to set it. We'll set it to something like, let's do 180 degrees in 1 second. And let's create a 3D object, cube. We'll make it 0.2 by 0.2 by 0.2 by 0.2. And I'll take our collectible, move it up so we can see it. And then I'll take our cube and rotate it just a bit so it's catty-cornered. Now when I press play, should see the cube rotating. Yep, there we go, there's our collectible. And now we need, okay, we've got our box collider, but we need this to be a trigger and not a collider. We also want to make our collectible a child of the platform, but I don't want to do that yet until, let's refrain from doing that until we have this as a prefab. So what I'm going to do is I'm going to test to see if we can collect it, then save it as a prefab. So let's add another function, say on trigger enter, collider other. We need to add a tag to our player ball. Okay, our sphere has the collider, so let's add the tag to that, call it player. And save our scene, go into crazy tilt, go into our script, rotate, and say if other dot game object dot compare tag is equal to player, then it'll run this. We'll say we need to add to a score, so let's add a game manager as well. I was just thinking that. So I'll create it empty, call it game manager. We'll add a script. game manager script. Open this up. Also do need to get some notes about making this a global singleton, because I can't remember for the life of me exactly how to do this every single time. There we go. We've got the global singleton format going on. Alright. So we've got our game manager. Double click it, open it up. Come on, Visual Studio, you can do it. Promise. There we go. Alright, so at the bottom, first thing we're going to do is we're going to make a region instance so we can collapse it. And we'll do hashtag end region, or pound in region. Private static game manager s underscore instance is null. This is public static game manager instance get if the static instance is null, then our static instance variable is find object of type of game manager as a game manager. And then we'll return our static instance. And then one last thing, we need to make sure to clean this up when our application closes. So void on application quit. We're going to take our static instance and set it equal to null. Okay, with all that in the way, with all that out of the way, we can minimize that region and start working on our game manager. First thing I'm going to do is going to make a variable for our score, int score, and we're going to make it public actually. Yeah, this is going to be a really small project. It's okay for this to be public and accessible from anywhere rather than set score and add score. It might be best practice anyway to have a setter and a getter, but I digress. Let's just focus on our collectible, which I did put this in the rotate script. Don't know what I was thinking. Let's cut this out and create a new script called collectible, just in case we want to use that rotate script somewhere else. So go to our collectible, create a new, and say, just call it a collectible script. Add it. There we go. Let's open this up and let's destroy, start an update, and let's paste in what we just copied. So our on trigger enter, collider other. Now we have the player. So if the other collider was belonging to an object that had tag player, then we can destroy it ourselves. So destroy this game object, and we can also add to the score. So game manager.instance.score plus equals, let's say 100. Okay, cool. Now let's add a function in Game Manager to manage some UI elements. So let's do using Unity engine.ui. Create a function called update score. It won't return anything. And then create an object that's a text object. So public, well, it doesn't have to be public. Let's say, yeah, it does actually, because we have to assign it in the inspector. Public or serialized. Could be a serialized field. Let's do a serialized field. Yeah, serialized field text, and we're going to call it score text. Alright, when we update our score, we're just going to say score text equals score.toString. We could also add a string before this that says score semicolon, space, and add a plus to concatenate these string elements. Okay, awesome. So I should collect 100, but we need a display for our score. So let's add a canvas by just going to UI, text, it'll automatically add the canvas. Change the screen space from overlay to screen space camera. Pick up our main camera from the inspector or hierarchy, then go to render camera. We're going to set, well, our sorting layers don't matter right now. We're working in 3D. We're going to go with scale of screen size, match height, and our reference resolution is going to be 1080 by 1920. And it's pretty close to that ratio. It's not exact, but it works for me. Alright, and then you can change the plane distance from the camera here. Instead it's something like maybe 20. So now when we go to our text object, let's make it something like 36. And increase our width, increase our height, till that text appears on our screen like that. Good. Let's make this bold and a white color. Maybe it'll need to be 72 point font. Who knows? Let's see. We'll just put a little placeholder. Score 0. Awesome. Now we can move this around the screen and kind of position it how we need it. Let's put it. Instead of having the player look down, let's just put it at the top left corner. That's a good safe spot for it. We'll align it left and center. Okay, just to add a little bit of polish, let's add an outline component, and we'll change the effect distance to something like 4 by 4. 4 in the X, 4 in the Y. And then change the alpha to 255 so it's really dark. Finally, we're gonna just rename this score text and drag that into our game manager script. Okay. So we're going to test collecting the collectible despawning, and then modifying score text based on the score, which we do need to call update score after this is destroyed. So we've incremented score, and then we'll say game manager.instance.update. It is not public. Let's make this a public function. Public void update score. Save that. Now you can find it in the list. Update our score. Awesome. We hit play. Nice, now we got our player. Now that collectible is not following the board just yet, but oh, I feel like we just missed it. Here we go. Now that's the problem. Alright, so I have some ideas about what may be going on and what may also prevent our player ball from clipping through the map. So I'm going to move our player ball into the platform. I'm not going to apply the platform as I'm not going to apply the ball on the platform as part of the prefab. I'm going to do the same thing for the collectible. Now when we play, the ball should update its position relative to the platform, but the platform shouldn't be able to just fling it off. There we go. So we've got that direction we want. Our collectible follows. It runs into the walls like it's supposed to, and it doesn't. Yeah, okay. So this is easier to control. I am actually not getting any debug logs from our collision. So let's add one on our on-trigger enter. Collectible on-trigger enter function triggered. Then we'll know whether it's a tag issue or whether it's actually the function just not getting called. I can't tell you how many times I've kind of messed up on this one, but alright, so it's not getting called at all. That's the problem. Alright, I think I know what may be going on. Let's change this to destroy other.gameObject and change our other tag to collectible. We're going to save this. Then we're going to take the collectible script off of the collectible itself. We'll leave the cube, which is the physical part of the collectible, tagged as collectible, and then we'll go to the collectible parent and copy the component, then remove the component. Then we'll go to our player ball, our sphere, which is the layer where we're going to get our physics events, and I'm going to paste component as new. So now when I press play, it should. There we go. That's what I thought. Alright. So the collectible, the on-trigger enter would not trigger for the collectible because it was not moving. The player is what's moving. So that's why I was confused. So definitely put collectible on the player, and then it'll increment our score. Problem solved. So now what we want to do is we want to go to prefabs. We're going to take our collectible. We're going to create a prefab of it, and in the prefab, let's open the prefab. Let's zero out its position so that wherever we spawn it, it's zeroed out. Alright. We don't need to apply any overrides. Player ball. We do need to apply some overrides for this. The collectible script. So apply all. And when I open up our player ball prefab, okay, just check that the position has not changed because we have repositioned it in the world. And we've put it under our platform so that it doesn't fly off when the platform rotates, which is great. So one thing that's probably annoying you guys as much as it's annoying me is that Unity Remote 5 keeps changing orientation on your phone. So what you should do is go into build settings, player settings, go to resolution and presentation, set the default orientation to portrait, and then it won't do that anymore. Alright, now that that's done, let's create a new material, and we'll make it collectible matte. We will call this, I don't know, red, super metallic, with a little bit of smoothness. Feel free to just go crazy with it. Let's open our collectible prefab by hitting this little arrow next to it, or going to open prefab over. It actually doesn't. Oh yeah, here it is on the right. Open prefab, and then you get into this local space here. Now we want to go into our cube, and we want to drag this material over. If you press F, you can focus on the cube. You hold Alt and left click, you can kind of orbit around it and see how the light plays off of it. That's pretty cool. We can also change the collectible material shader from here. We can make it transparent if we wanted to. Change that alpha value just a little bit, bring it down. We could even add some emission to it, but that's not really going to do anything unless you have post-processing enabled. So I was just going for some slightly transparent, illuminated object. We don't really want it to, you know what, we might actually want it to have some emission. wanted it to be shiny, but I guess we're gonna need that. We're gonna need post-processing for that. In any case, let's not worry about post-processing, and it doesn't really matter whether it's transparent or not. Okay, let's go back to our main scene. You can see our cube sitting there. Take our collectible, Control D, duplicate, and just put it around the map. Now what we want to do is set up our game so that when all of them are collected, it gives us a game over, or level completed. So in our game manager, or actually in our collectible script, we can update our score and then call another function on game manager, public void, or yeah, public void check remaining. We'll call it that, and we'll say game object array collectibles, and assign the value of game object, capital G, dot find game objects with an S, with tag, and we'll give it collectible as a tag. And that's going to grab all of our objects that have collectibles. And we'll say if collectibles is exactly equal to null, or none, basically. Because this find game objects with tag, if you look at it, wish I could see more information on it. But if you were to look it up, if you were to look it up, you would find that it does return null if it can't find any. So we'll say non-remaining. Let's add a boolean level completed. We'll say level completed equals true. And we'll just make that public for ourselves right now, so we can see, oh yes, we did collect everything. And before we go any further, let's go into our platform once more. Let's actually take our collectibles and our ball out for now. Put it at the bottom of the stack. Our platform needs one more thing done to it, where we take our ground, Control D, duplicate it, bring it up. Now let's grab a corner using V and bring it down. We'll create one final material. We'll call this ceiling mat. We'll keep our metallic at 0, drag our smoothness to 1, and then set it to transparent with a really low alpha value. Actually, you could go all the way down to 0 with this one. We'll take our ground 1, which was what we duplicated and moved up. We're going to call this ceiling. And then we're going to drag and drop our ceiling mat onto this. And now you'll see, when you fly around, you'll see that it reflects the sky as if it were glass. Okay, so definitely apply all overrides with that ceiling. Then take your player ball and all your collectibles and drag them onto the platform. Awesome. So when we press play, now we can see on our screen that it's always going to be oriented correctly. 1. Number 2, we can turn this however we want, as fast as we want, and we're not going to lose the ball, which is wonderful. Alright, so we collect all these objects, and let me select our game manager so we can look at it in the inspector in real time, this level completed checkbox. If we get that last collectible there, that should tick on. Interesting. Interesting. Ah, you know why? It's because we didn't go into our collectible script and then call that. Game manager.instance dot check remaining. And before we test again, let's just take one of these walls, and we're not going to apply it, but let's take one of these walls, Control D, move it out just a little bit, scale it in one direction, Control D, duplicate it, drag it around, maybe stick it to this wall over here, and we can take our collectible and move it, you know, in this corner. Okay, let's give it another try. We start. We're trying to collect all the balls, or all of the rotating cubes. Now that I think about it, that transparency on the cubes was, or the emission on them was completely unnecessary, but they do stand out, which is good. Alright. So if we watch the game manager, it should check level completed once I do get all of these. Now the ball is moving a little slow for my liking. We could increase its mass and it'll move a little faster. But once we see game manager did not check level completed. Check remaining is after every time it's collected. You go over here. If collectibles equals null. You know what? Maybe it's not null, maybe it's returning an empty array. My mistake. Collectibles dot length equals 0. So when it has 0 length, check it to true. I'm just gonna, instead of playing it, I'm just gonna grab the player ball, move them around. Collectible, scores incrementing, sweet. And now, collected everything. There should be nothing left. Game manager. Why? Why? Let's say, debug.log collectibles.toString debug.log collectibles.length.toString. So when in doubt, get out the debug logs, and then you'll be able to see what's going on. Grab the player ball. Alright, so I collected 1, 4, 3, 2, 1. Okay. Okay, so that was the problem. It goes down to 1 and not 0. Who'd have thought? So if collectibles length equals 1. There we go. That was the error. We found it. And I believe that about wraps it up for the first video. This is the outline for our game. In the next one, we're going to add a little bit more complexity, create a second level, and then add some menus to our game. So I'll see you guys in the next one. Hey guys, welcome to part 1-2 of the creating an item collection game and integrating mobile ads with AdMob. In this one, we're going to be finishing up our gameplay by adding switches, doors, and some level complexity. And then after we create 2 levels, we're going to create a menu for it. This is going to be pretty simple, but also off the cuff. We're just going to kind of wing it as we go. So without further ado, let's get started. Open up your project. Make sure you have your phone with Unity Remote 5 so that you can test. And we've got our sample scene open. Let me actually rename this. Rename level 1. Sure. Alright, so it reloads it. Now let's create level 2. Okay. So we've got our collectibles. The collectibles are rotating, and they are collectible by the player. So this is our first level. Let's try and create a new kind of obstacle. First thing I'm going to do is I'm going to create an empty object. I'm going to call this gate. And I'll zero out its transforms. So reset everything. Then I'm going to create a 3D object under it. It's going to be a cube. Big surprise. Make sure it's a child of that. And we're going to call that gate mesh. Now let's go into our materials and create a material called gate map for gate material. We'll just make it, I don't know, like cyan and transparent. And we'll bring down the transparency of the mesh, or the material down. Then we'll increase the smoothness just a bit to like 0.8. Maybe, I don't know. Nah, it doesn't need any metallic. Okay, so we'll take our gate mesh and we'll drop our gate material on it. Sweet. So if I press F to focus on it, it's actually in the floor. But it is slightly transparent. And let's bring our gate up. And then we'll mess with our gate dimensions here. So I'll position it right along this wall. If I press V and snap it to the corner of the wall, that's helpful, but not exactly what I want. I actually want to kind of center it and then mess with the scale. So let's mess with its, that's a bit of a problem. Okay, yeah, go to the gate mesh itself and mess with the Z scaling. Make it a little bit more thin. Then mess with the X scaling and then the Y scaling to shrink it down just a bit. Okay, so I'm going to take that parent, I'm going to drop it down just a bit so that it's right over the floor, and then I'll make sure this wall is kind of flush with our gate, or our gate is flush with the wall. Cool. So now we can do something really simple. We can open up a new window, animation, and let's anchor it down here where we can work with it. Let's create a new animation for our gate. Now that I think about it, it might actually be better to create an animation for the gate mesh specifically. That way the gate can inherit transforms from the platform, and then the gate mesh will animate in its local space. Actually, it should work either way, but let's continue. Gate animation, gate open. Let's call it gate open, yeah. So we've got our gate mesh animator and our gate open animation. Cool. So for gate mesh, gate open animation, let's create a new clip called gate close. Actually, we don't actually need this. We don't need this. Cancel. We can run our gate open animation in reverse. So the first thing we're going to do is hit record, and then let's add a property, transform position, add that there. Okay. Now when we go to the end, we can modify this position like so, and then stop recording, and then when I scrub through, it opens like that. If you want to see the curves, you can hit curves down here instead of the dope sheet. And if you wanted to make it go faster, you could drag it in, because this is 1 second. Let's make it half a second to open. Nah, even faster. There we go. So let me press play. Awesome. Okay, so now we need to go into our animator. So double click this, open up our animator. Gate open, that shouldn't be the default state. Let's make an empty. So create state empty, and we're going to make this our default state. So click this, right click, set as default layer, and just say empty. Okay, now we'll connect gate open, make transition to gate open. We'll create a parameter over here, go from layers to parameters, add a parameter, say boolean, say be open. And let's say if be open is true, then it will run this transition. At speed 1. Then if, let's make another transition and we'll say if gate open is false, then it'll make this transition back. So let's see. Probably should make an empty state instead of just an empty. I was thinking we could run this animation back in reverse. And there's no preview available, of course. But let's just see. Yeah. Let's actually change our empty state to another animation just to be safe. Alright, so add a new clip, go down to animation, create new clip, gate close. You know what? For our gate open, we really don't need the first value. It doesn't, the transition is handled in the animator. Don't know why I forgot, but let's Control D, well, let's duplicate this, Control C, Control V, and then override the initial. So it'll always be locked in the open position. Then we'll go to our closed position and we'll just add property transform position right there. Sweet. So close, open. It was at 0.2 seconds, but regardless, we can change the rate of transition elsewhere. So let's just make them equal to 1 second of just static. So if you were to play either, it would either just be open or closed. And then when we go to our gate mesh, we're going to make this the default state, delete this empty, then make our transition, right click, make transition, and then we'll move our timeline so it's a little bit tighter. Add our condition for be open true, then add a condition by clicking or selecting it, make transition, selecting that transition, tightening up our timing here again, and say be open false. And actually this timing can be a little bit slower. Alright, so we're going to set up a timer that'll open or close the gate based on a switch being run over, activated. It'll deactivate itself. When it deactivates itself, it will talk to the gate. Okay, so in order to govern this gate's animation, we are going to need a script. So let's go into scripts, right click, create, and say gate, just our gate controller. We can single click this name to rename it, gate controller. Alright, so let's open this up. And what's interesting is we can make this gate controller something that we put on a switch rather than we put on the actual gate, and then we'll drag and drop the gate in the inspector so that it's just like a remote. Let's set up a trigger first. I'm gonna actually make this a prefab and then create a trigger. So create empty, zeroed out, reset position. Let's add a 3D object, let's say it's just a cube. It's going to be a little switch. Make it about, I'd say 40% of its original size, so 0.4, 0.4, 0.4. And then we'll move this gate, or sorry, rename this game object. We'll call it switch. I'll pull it up. This has a collider, but we want it to, we're not going to have it depress. We're just going to have them go over it and then change color. So this cube is going to be our switch. Yeah. So let's make it a trigger, and then let's also give it a tag. So add tag, we'll call it switch. All right, cool. So we go to cube, add switch on our switch. So now we need to go to our player ball sphere collectible script. Now I'm thinking about it. This collectible script could have been named differently, and we could put a whole bunch of other collision functions, but let's just use this to govern our collisions for now. So it'll be in collectible. You can always rename the file and then rename the header. Well, this is going to handle our trigger events, because the player is going to be what's moving, and it's going to initiate the event. So on trigger enter, if it's a collectible, do this. Cool. Well, we'll do if other.gameObject.compare tag is a switch. Then what we want to do is we want to go into that object. So we would say other.gameObject.getComponent, and we're going to call it, what was the new script we made? Let's move collectible in here. Let's move rotate in scripts as well, just to stay organized, and our game manager. I guess our game manager can stay out here. Okay. Gate controller is what it's going to be called. Cool. Oh, and this actually needs to be rebuilt. So let's close this and open it again, because Visual Studio builds solutions. There we go. So now it sees it's part of the project. We moved it from the initial folder that we were working in. So let's start over. Let's say if other.gameObject.compare tag switch. Then we'll say other.gameObject.getComponent, and we'll be looking for a, what was it, gate manager or gate controller, if I am correct. Yeah, gate controller. Public class gate. Let's call it gate controller so that it matches. This class name has to match up with the actual file name. Okay, so now it finds it. So we get component gate controller, and we'll call a function. Okay, so we'll do to call activate gate function, and then this will manage. We're going to make a function in gate controller that's going to manage its own timer. Say float timer, and then at start timer equals 0.0, and we'll say public float time. So this is going to be our 0.0f time is going to be how long the switch should be active. So maybe we could call it switch delay instead of time. That's going to be set in the inspector. And we'll say we need more functions. Let's do public void switch or gate active or activate gate, because this is going to be a one-time event. So activate gate. You just want to keep your verbiage relevant. So when we activate gate, we're going to say timer. We do need a boolean. One more thing. And let's make it serialized so we can see it. Serialized field, bool, gate active. Okay, so activate gate. Alright. Gate active equals true. So in our update, let's make it fixed update, because this is going to be dependent on time. We're going to say if gate active, then it kicks the whole system into gear. So if gate active, we could say switch, let's see. There's two ways we could do this. We could count up or we could count down. Let's count up. Timer plus equals time.delta time. Alright. And then we'll say if timer is greater than or equal to switch delay, then what we're going to do is we're going to deactivate gate. And then we're going to say timer is back to 0 and gate active is now false. But let's do that and deactivate gate. And we can add other things such as like material color swaps to this. Alright, simple as that. So what we should do is we should probably add some kind of visual hint as to like whether this switch is active or not. I'm going to make this a prefab real quick. So switch prefab, and I'm going to open the prefab and make sure these are zeroed out. Excellent. And then I'll place the switch somewhere over here. And in the gate, let's see. The switch is going to manage. Yeah, that's what I thought. The switch is going to manage the gate. So what we do need in our gate controller is a reference to the actual gate. Yes. Okay, sure, let's do that. So public, or let's do serialized field. Serialized field game object, capital G, gate, and this is going to be the one to activate. So we're going to have a gate controller on every switch, and then it'll activate that particular gate. And when it activates that gate, we're going to find the animator on it. So in activate gate, let's do gate dot get component in children. We're going to call it animator. And then we'll say play. And then we'll give it the state name. Oh, I'm sorry, not play. Let's do set bool be open to true. Alright, and then we'll set it in deactivate gate.get component in children animator set bool be open false. This way I can just drag the prefab in, the parent, not the child. So if the switch is collapsed, I can just go to our gate. I'm going to take our gate, if the gate is collapsed, we can just drag it into our switch function. Anyway, let's add this to our, let's add this script, our gate controller. You know, it's really funny how that works. So if I go to, okay. I moved that and it made a copy. Very strange. Let's go to assets and just delete this because we don't need it. Yeah, it's not on anything anyway, I don't think. Let me just double check. Our collectible. No, it's going to be on the player. Player ball, sphere. Yes, okay, so it would show up empty if we had deleted the wrong script. Sorry for the sidetracks. Let's continue on. Gate controller. This goes on our switch. Cube. Gate controller, drag and drop. Cool. The actual gate, take the gate parent prefab, drop it onto our gate slot here. This is our delay and how long the gate is, and whether the gate is active. So let's say we want it active for 5 seconds. Switch delay 5. Okay, cool. So now what we need to do is we need to take our gate and our switch and put it on the platform itself as children. There's not going to be any material swaps, but it is supposed to trigger this animator. If I am correct, be open was, yes, that was the trigger. So it should get the component in the child of the gate, so the gate mesh, it's going to go to the animator here, animator's gate mesh. If we open that up, that is where our setup was. Alright. So let's hook up the phone, get Unity Remote 5 open, and then press play. Interesting. It's running, but it's not getting my input. Gyroscope is not supported on this device. I just used this in the last tutorial. Or the last project video. My bad. Okay. Let me plug it in again. Go to edit, project settings, editor, any Android device. So it's not detecting it. Let's go to build settings, go to our Android, run device. Let's actually pick the correct device and then press play. Let's see. Oh, there. That apparently fixed it. Who knew? Okay, so there's a trigger over here. I hit the trigger. That's a little frustrating. Okay, so our switch has a cube which has a box collider which is a trigger. It is tagged with switch with the capital S, and if we look at our collectible script, we are comparing over the tagged switch, but we aren't calling the function. That was my bad. Okay. So let's activate that gate function. So if other.gameObject.getComponent.gateController dot activate gate. There we go. Simple as that. Maybe we can fix this. Alright, I hit the gate. The gate opened. 5 seconds later, it closes. Excellent. Let's go hit the switch again. Oh, it's open. Get through the gate. Get through the gate. Get through the... Okay. Ah. Okay. So it works. Excellent. One thing I would like to do is increase the responsiveness of the player. These are just little tweaks here and there. Before we get into the whole material color swap. So what I'm going to do, I'm going to take our ceiling material and I'm just going to plaster everything with it. The floor, the walls. This is totally optional, but I noticed that when I tilt down, I can't see the player, and it's a little frustrating. So I'm going to make everything this transparent kind of plexiglass material, and I'm glad that I made the gate its own color. And then the collectibles their own color. And let's also go into physics. Let's go to project settings, physics. Up here at the top where it's gravity, let's set our gravity to something like, instead of 9.81, let's set it to something like 24.81. And now we should see a higher degree of acceleration. Yeah, there we go. So the ball, yes, this is much more fun. Much more fun. Immediately. So responsive. And when you're tilting forward and down like this, you can actually see where the ball is. So that's a big plus. Excellent. So now we've got this gate and it activates, but there's no visual feedback for this switch. I would like it so that this actually changes color. Let's make a switch material in materials, and I realized my animations are in my materials folder. So let's do some organization. Go back to assets, create folder, call it animations. Go back to our materials folder, grab our animations and animation controller, just drag it and drop it into our animations folder. Cleans up our materials, great. Okay, so create new material. We're going to call this switch mat. Awesome. And then let's change the rendering mode is fine. What we could do is make it a I'm just thinking of our color scheme. We've gone with like really saturated colors from now on, or from the get-go. So it might be helpful to stick with saturated colors. Thinking about what might look good as a switch. Red is the color of our collectibles. So maybe a green for the switch and yellow when it's active, I'm thinking. Maybe something more satisfying, like a cool color. So we go from green to cyan. Green and yellow kind of complement one another. Let's go with green as a default and then have yellow is our activation color. Okay, sweet. Since our gate controller is on our switch, we should be able to just go into our own renderer. Let me verify, yes, gate controller is on our switch. And our mesh renderer right here has our list of materials. Now we've got switch mat. If I go to switch, I do want to override all of it actually. Let's apply all of that. So when we open the prefab and we drag in another switch, it does have the green. It didn't have the transforms. I'm so thankful that didn't stick. Then we've got our material. Great. One thing we may want to do to the switch material, make it transparent like everything else in this game. But mostly opaque. Okay, cool. Now that we can say for certain that we're going to have a material, let's make a new material, a private material, and call it switch mat. And then on awake, let's make this on awake instead of start. We'll say switch mat is assigned the value of mesh renderer. We could do this.gameObject.mesh renderer, or .get component, or for shorthand we can just do get component mesh renderer. Don't know what I was thinking. Now let's say dot material, and this is always going to give the first index. There's only one material, so we don't need anything else. If you have more than one material on something, you could do materials and then do index 0. Either way, this works, surefire. Then let's see, when we activate gate, we are going to have to store this material. Let's say material temp. No, we don't need to store the material. We just need to get the color block. No, yeah, we do need another material. Let's just go with it. Activate gate. Switch mat dot color. Yeah, we're gonna need a temporary color hold. So let's see. Color, temp color. This is gonna hold our color when we swap. So we'll say temp color is exactly equal to switch mat dot color. Alright, get color. No, it is color. And then we'll say switch mat dot color is color dot yellow. Being a lot less exact with our color too. But when we deactivate the gate, we just want to reassign our temp color back. So switch mat dot color equals temp color, or assign the value of temp color back to switch mat color. Hopefully this works. Hopefully I can just access the color directly without using the getters and setters and all that. But we'll see. So when I hit it, it turns yellow. Excellent. And then when it deactivates, it got turned back into temp color. There's one surefire way to do this. Let's do color idle color, and then we'll do color active color, and we'll say switch mat in our awake, we can set this, or in the inspector we can set this. Let's set it in the inspector, because we change our mind all the time, and this is also more designer friendly. So let's do color active color. Alright, so we'll set that in the inspector. So we'll set it to active color, and then when it deactivates, we'll set it to idle color. Excellent. So we'll go to our switch. We've got our idle color, which is going to be this deep green. And I know I went with transparency, but let's just keep it at like 230. Then we'll go to our active color, which is going to be yellow. We'll make the alpha like 230 as well. Sweet. Now let's apply the script overrides we set. Test one more time. We know the gate works. We just want to get the color change right. So idle color, active color, and then when it closes after 5 seconds, back to idle color. Great. Excellent. Now you could extend this system and you could make it so that you have to hit XYZ switches in order to get it to work. But let's just stick with this for level 1, and let's also take our little wall here, move it over, and scale it out. Let's take it on the V, hold V. Oh, I can't snap it to a vertex because that's not, alright. Let's just get as close to this edge as I can and move it over. But what I want to do is I want to make this flush to this wall and then also interact with this gate. And I like the size of the gate, so we could make this wall a little bit bigger than we need it. It's okay if there's a little bit of overlap. Everything's transparent, so it's going to look like it's part of the style anyway. Cool. Okay. We can also change our skybox to be more interesting. Actually, go find HDRI Haven. Sorry, HDRI Haven has some good free HDRIs to download. Let's get some. Let's get some night themed ones. I think that would be kind of cool. Something that'll look really interesting, reflecting, but also has kind of the color scheme or feel we want to go for the game. Feel free to just pick whatever you want for this. And I'm just going to download the 1K HDR. And I'll grab it and I'll put it on the desktop and bring it into the project. I'm just going to drop it in our main assets area. Cool. Now to change your lighting, you just go to Window, Rendering, Lighting Settings. And for your skybox material, you may actually need to create a new skybox. So create new material. I'm going to call it Sky. Change our shader to Skybox. Panoramic. And then grab our night sky. Then grab our new sky and put it in the game. Alright, this did not work the way I wanted it to. The tint color is way too light, first of all. We also don't have the right level of exposure. I feel like, yes, it's quite possibly being reflected. It's just not. It's not being reflected in the material the way I want it to. Specular highlights and reflections are active. And this is going to be a mobile game. Let's just change our skybox again. Oof. Let's change it back to default. Because the sky does a good job of lighting up our glass and making it look like glass. We can change our intensity. Oh. Well, anyway, we do have a directional sunlight, so if you want to make it different, we can change it so it is different. Alright, this is not working the way I planned. This actually has to reload all the reflections every time I do this. Okay. I don't need this guy anymore. Alright, so let's just play with our lighting a little bit. We'll go to our main camera. We'll say solid color background and we'll make it black. Sweet. So now we can, well, maybe not black, maybe so we can have the outline around the score. It looks pretty good. Maybe we could get by with another accenting color as a backdrop. Oof. Never mind. Let's just leave it black and play the game. Let's see what it looks like. When I move the board around, we should see a reflection of our skybox. Yet there's enough contrast to see all the elements of the game. Okay, good. That's what I wanted. And now the gate's on the wrong side. I mean, the switch for the gate is on the wrong side. But, to be fair, we would need to go both directions. So let's duplicate this switch and put it somewhere hard to reach on this. Maybe not hard to reach, but let's give purpose to this little nook we have right here by moving our switch into this corner. And let's make our other switch a part of the opposite corner. Well, it is. It is. Okay. Trying again. So now that I can go to the right, hit that switch, open it, come down, hit the switch again. That's interesting. Alright, hit that. What I was saying that's interesting about is that you can potentially activate both switches and then it will stay deactivated even if the other switch is active. This is because each script is managing its timer independently, but that's okay. That's okay. We only wanted it to stay open 5 seconds, that's what it'll be. Okay, so that's our first level. We've spent enough time on that. Let's now move on to level 2. So I'm going to save this level. I'm going to apply any overrides that I have on our switches. No overrides on our gate. Okay, cool. Let's reconstruct level 1 and level 2. But this time do it differently. So we'll take our platform, prefab, bring it in. It needs to bake lighting. Oh, there needs to be material changes. Let's put the ceiling material on everything. Alright, now we'll take our directional light and, oh, not a directional light, but our camera, and we'll say solid color, black. Window, let's go to our rendering light settings. Our sun source is going to be this directional light here. And we are going to have a default skybox material. Let's generate lighting. Cool. Our main camera is going to have to be repositioned again. I think we had Y equals 10, rotation 45, and actually, no. Let's save this scene, go back to level 1, go to our main camera, copy component for our transforms, go to level 2, go to main camera, go to this cog, and paste component values. There we go. Now we've got the same camera position. I believe in camera in level 1 we had a camera field of view of 35. We could also make a prefab for the camera. That would make this a lot easier. Let's just do that. Go to level 1, grab our main camera, drop this into prefabs, save it, go to level 2, grab our prefab camera, we'll delete the main camera, grab our prefab camera, drop that in at the top of our stack, way at the top here. And, oh, I accidentally put it on our directional light. Let's not do that. Let's put it down here so we know it's not appearing on top of anything. Now move it up to the top of the stack. Okay, cool. So we've got our platform. What's next? We need our player. Grab our player ball, put it on any arbitrary position on this platform, move it up so it's above that surface layer, and we'll just start it out in this corner. Now for the level. We're going to take some of these walls, just duplicate and resize them. So Control D, move it over. Let's scale it in, create kind of this two-path junction here. Then we'll duplicate this. We'll duplicate this. Trying to think about how we could do this. Duplicate one more time, and then let's rotate it 90 degrees. Sorry. There we go. Let's scale it in a bit. What I want to do is I want to kind of create caps for these end pieces. Just eyeballing it at the moment. Okay, so that's like the giant S. In the middle, thinking we could have some kind of mechanism. We could actually move this over and add a gate to this side and this side and this side. Or we could duplicate this, move it over, change its thickness. So it's a little bit where we want it, a little bit closer to where we want it. Right now I'm just creating a level out of thin air. If you guys want to make your own, by all means, go crazy with it. But what I'm going to do is I'm going to add a switch to this. Make sure you raise it up above that platform so you know the player can hit it. I'll drop this switch right here. I'm going to add a gate to our platform. Move it over. Remember, it opens this way to whichever direction is to the right of it. So we should rotate it and position it so that this will work. Our gate's at the right height, surprisingly. Cool. It's a little bit hard to see with the transparency what's going on in terms of where things are being positioned. But now let's take our switch, drop our gate into it, and then make the switch delay like 3 seconds. That's going to be a little bit harder. We're going to take our other, we're going to take, let's add another gate to the platform. Right about there. Now, if this is going to open this way and we rotated it that way, then this is going to open this way. So we do need to rotate this. I'm holding control for increments again, just so you know. Then you take this switch and duplicate it. It's already at the right height, so Control D. And let's move it over here. Alright. And we'll just make it simple. Take our new gate, drop it in. Oh, that's interesting. I duplicated this, so yeah, we're gonna have to override our previous gate. There we go. And it'll be another 3-second delay switch here. Let's test out our switches first. Wait, we do need one more switch to open this gate once more. So we'll put it over here, and we'll make this one a 5-second switch. So you can have a little bit more time to get back to where you were going. And you know what, why not? Let's just add our collectibles. There's no reason why we can't add our collectibles right now. So let's just do it. So move those up to about the level the ball's going to be at, so you can collide with them. Let's duplicate it many times over. I know my spacing is not the best. It's gonna bug me. It really is. Okay, let's do a play test of our level 2. Alright, so first thing I want to do is I want to get these first collectibles. Oh, we had an LREF. Object's not set to a instance of an object at line 14 for our collectible. So we go to collectible. We go to line 14, game manager instance. We do not have an instance of the game manager in level 2. Now we will when we play the game and go to level 2 once we get our scene management in. But for now, let's just go to assets and drop a, darn it, we need an empty to hold it. Okay, create an empty, we'll call it game manager, and zero out its transform. So reset position, and then drag our game manager script onto it. Cool. Another thing we're missing is our score text. Let's go back to our level 1 scene. Copy the canvas, go to level 2, and paste our canvas. And drag our main camera into the render camera slot. Sweet. Now I need to go in my game manager and put the score text into our game manager. Our game manager should not reset the score to 0. Good. I was just double checking. Let's save our scene and let's test again. So we move forward, we can collect things, our score increments a whole lot. It's level 2, it's a little more challenging. We get this, we hit the switch. Awesome. It activates just the way we wanted it to. Oh no, I didn't make it in time. That's the other thing. Alright, so go, 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 go. I made it. It's possible to win. Promise. Oh, that's not the way I wanted it to open. Ah. Alright, now let's see if they need to get back. Boom, I open it again. Oh, see, that's impossible. So this is why we play test. Knew that was going to happen. Alright, so for our final little run at the end, this one actually needs to be rotated 180 degrees. I knew, just knew I was somehow getting that wrong. But this should work. Real quick playtest again. 90% of game development is trial and error. Okay, we got it in. Cool. Open it up. Come back. Boom. It closes. Let's hit the switch again. See if we can get back in time. See if we can get back in time. Oh! Made it. Okay, so we need that. Oh! So we have no way to backtrack. I've missed some in the beginning, and it's impossible for me to get back. That is a no-win scenario, so we are going to need another switch. And I know exactly where to put it to. We can put it right here, or we can put it over in this corner. Let's put it in the corner. All the reactivation switches we could just shove in a corner, and that would be a way to do it. But let's see. It really wouldn't matter though, because as soon as you use a switch, the player's going to know exactly what it's for because they're going to see the end result. The challenge in this game is staying oriented as the board is constantly shifting around. Alright. And it's okay that that's by a collectible, but I'm just going to move it over just so it looks a little better. Because why not? Okay. So this switch that we just placed was a copy of the other switch, and it should move gate. And gate is here. And that's exactly what we wanted it to move. Awesome. Awesome, awesome, awesome. Okay, last thing we got to do in this part is we need to set up a menu in our game. And eventually have our game manager actually switch between the scenes. So main menu, let's add a canvas, let's do UI, let's just do text. Change our width, our height. I'm going to call this Crazy Tilt. And font, I don't know, grab, you know, I've got a folder full of fonts. I'm just going to bring some in here so it doesn't look so boring. Let's say fonts. I'm going to go find my fonts folder. So if I go to fonts, let's drag infinite in. That works. And we go to our text, which this canvas is not even on the camera. RIP. How about render camera here? We've got to make it scale with screen size, match width or height, match height. And we're going to do 1080 by 1920. Okay, so where's my text? Let's go find it. It's right here, really tiny, very hard to see. We'll make it white. We'll change the font style to infinite. We will make the font size a lot larger, like 100. Change our width. See, it won't even display if your height isn't enough. There we go. Now we've got crazy tilt. Center it, center it. I'm going to go into 2D view so this is easier to edit. You can just drag it up. And you've got guides and everything. Cool, crazy tilts. Let's add an outline. I'll make it black with lots of alpha. And let's give it an effect distance. Ha! This is pretty cool. I'm not sure if I want the Y the Y offset for this. It looks pretty cool as is. Just experimenting with different titles. Man. Okay. It's gonna look a little jagged. See that? But it makes it look like a title, so I don't really mind. Anyway, let's duplicate this. Oh no, we don't need to duplicate it. We need to create a button. Let's say UI button. Wow, that's really small. Let's increase the width, increase the height. Let's change the text font to the font we're using now. Increase the font size. That's a little better. All right. Just experimenting with different things that they have here. This looks fine. Really, this button is just going to be play. I'll move it up. Grab my title, move it down just in case any of you want to experiment with putting a border on top. So we've got play, and then let's do a ×2 reward button. Play X2, and it doesn't need an exit because it's a mobile game and the platform handles that on its own. Other than that, yeah, this is all we're going to need. So what we're going to need now is a game manager instance, and we will go to assets, drop our game manager on this. What we're going to need is the game manager is going to have to use scene management. So using Unity engine.scene management. Okay. Now we'll have a function to be called from the buttons. So public void play pressed. And we'll say scene manager dot load scene, and we'll give it scene build index of 1. Our first scene is going to be 0. That's going to be the main menu. Next scene is going to be level 1. Then we'll say public void x2 press, and this is where we're going to do to do show rewarded video ad modify score times 2 during game. Okay, those are our 2 buttons. And then finally, let's make another function that's just going to be universal. So public void go to main for like go to main menu, and we'll do scene manager dot load scene 0. Then we'll also have public void go to next, meaning next level, or load next level. Let's do that. Load next level. Cool. Let's say if scene manager dot let's see, get active scene, and it returns a scene dot trying to find the build index of the current scene. Yeah, build index is build index plus if the build index of the current scene plus 1 is greater than scene manager dot get, if I get all scenes, oh, it's deprecated. Alright, what it's, well, I was trying to do get all scenes, and that's an index dot length minus 1 because we're doing index. Then run this. Go to main. So we'll say ran out of scenes, go to main menu. Or if you wanted to go to a game over screen, you could do that there as well. So let's see. Scene manager to get all scenes is obsolete. Use scene manager.scene count. Okay. Let's do scene manager.scene count. All right. -1. It should give us the proper index. If not, so else scene manager dot load scene scene manager dot get active scene dot build index +1. So go to the next scene. Go to next level if it exists. And really, you could make another scene that is the end, and then not even worry about this first part. And once you get there and you go to the next, build index, that would end your game right there, and you could have a way to loop back to the main menu, which actually would be an easier way of handling it. We would still need this go to main function for that last scene. But load next level, this is also where we're going to say well, let's make another function before load next level called public void level ended, and then in here we'll say to do show add between levels, and then to do load next level. Actually, we could just load next level now. Yeah, that works. So when level ends, which we have level completed equals true, and update, or level completed equals true, we could actually just call level ended from here. That works. And we'll show our add between levels and then load next level afterwards. Cool. If you guys wanted to make this more challenging, you could add a timer. So you have a certain amount of time to collect the collectibles. If not, you lose. That'll be a little frustrating for new players, but it's just a thought that crossed my mind. So now that we've got this set up, let's go back to our menu. We go to, okay, our game manager has, no, it needs buttons. No, it doesn't. It does not. We need to go to our buttons, label them, make this play button, make this X2 button. Then in our play button, we need an event trigger, add new event type, pointer down, so a tap. And then we'll take our game manager and we'll go find its function play pressed. Then we go to our X2 button, we do the same thing, add an event trigger, go to event type and say pointer down, add an event, drag our game manager in, go find the function X2 pressed. Okay, we'll save our scene. Now in our play pressed, we're going to load scene 1. That's done. Just to test, let's play. Alright, I hit play, could not be loaded. Aha, because we haven't set up our build settings. Genius. Let's go to our scenes. Scenes and build. Let's add main menu. Let's add level 1. Let's add level 2 under that. Cool. Now let's play. I'm going to test on the phone. So I press play. Cool, I'm in level 1. I open the gate. I've got 5 seconds to get through. Boom, we got a collectible. Boom, we got another collectible. Hit it. Got that. And the level is over. And it took me to main menu. Fascinating. So our build index +1 was greater than our scene count -1. Well, we were in 1. +1 would be 2. And scene count might actually return an index. Let's check. Let's check. This may actually be my error here. I press play. Got it. Got it. Let's open the door. Okay, gotta fall. Alright, level 2. It worked. So the count itself was actually an index, which is very useful, very helpful, but you know, if you're expecting a count, it's a little confusing. I was expecting a literal size. Okay, yeah, that does work, and you can backtrack. Awesome. Okay, we're back. We just played through our entire game. We got a play menu, X2 button, we've got switches, we've got gates, we've got our system that just keeps our levels coming. We've got our score, which should be going off of I'm actually going to have to test this. Our score should be compounding between each level. That's what we need to double check. So I'm just going to test this really fast. Okay. Oh, gate didn't open. Let me go get that. Got it. Back in. Okay. Yep, score is 0 at the beginning. So what we need to do, one last thing, as I suspected, score text is score to string. Yeah, that's cool and all. But on awake, for our game manager, we're going to have to check the actual score. So it should be private void awake. Score equals playerprefs.get int score, and we'll set it equal to score. Now, when I do get a collectible, it does update my game manager instance score, but it doesn't add it to a player preference, which means that it's not persistent between the scenes. So let's do player prefs dot set int. We'll call it score with a capital S, and we'll set it equal to player prefs dot get int score, whatever it was before, plus. You know what? No. In our update score, we don't have to do the math. The math has already been done in our game manager. So go to the game manager, go to our update score function, and we'll say player prefs dot set int score here to our score. And this will also save your score through multiple playthroughs, which is kind of not what we want. So let's do in play pressed, let's reset our score. So player prefs dot set int score to 0. Cool. All right, so that should work by itself. I will see you guys in the next one when we start actually tackling the AdMob portion of this. Hey guys, welcome to section 2.1 of our creating an item collection game and integrating mobile ads with AdMob. Make sure that you have your project open and then open a browser. Not this one. Open this browser and go to developers.google.com/admob/unity/start, and this is going to give you a getting started page. When you get here, let me just close everything out. You want to right click and open in a new tab, download the plugin, and that's going to bring you to a GitHub. Then you want to download this Unity package. Once it's downloaded, you go show in folder, right click, actually you can double click it and it will open and it will install into your open instance of Unity. Click import, and don't do anything while it is compiling, because yeah, otherwise you'll get a crash. It should actually start running Play Services Resolver as well. You don't want to interrupt that either. Okay, there we go. It's compiling. And I've got an error. Stop polling job due to exception. Missing method. I've run into this several times when I've tried to record before. But let's track it down. Fatal error. Let's see, that was 2016. What exactly is our error? Stopped polling job due to exception, missing method exception, Unity editor version control task. Just gonna, 1 day ago. All right. Version 3.1.182. Yep, that's it. Yes, there's a issue resolver. Oh, it has an issue with resolver. Try this one. Okay. So, oh man, I hate to do this in the middle of a project, but here, if I can zoom in, if you guys can follow me to this link, github.com/google-samples/unity jar resolver releases tag v1.2.124. If you follow me there, we can get the zip, and this is fixed regression with source control integration when using Unity 2019.1 plus. So this is kind of a hot fix that they put out. And I'm assuming once this finishes downloading, we can... Really, it's only 25 megs. It should be done by now. Oh, okay. Never mind. It said 25 megs downloaded. How big could this be? I mean, the package itself was really tiny. But I'm guessing that was compressed. Anyway, once this downloads... There we go. We've got it. Open this zip folder. Unity jar resolver. Let's drag this. Let's actually open it up and look at it. Exploded Gradle. Oh, there's the package we need. All right. So drag this package onto your desktop or somewhere like your downloads folder, then double click the Play Services resolver. Let's do this. Let's import the package. So in that zip there was a package, and now when you run the package that was in there, this should be a hotfix for the crash I've been getting. Yes. Just say yes. And then, let's see. It says moves obsolete file to trash. Wonderful. It's resolving dependencies. This is a process you don't want to interrupt. So I'm going to avoid minimizing or doing anything during this process. I don't even know if it's going to capture properly. If my computer's chugging too hard. Okay, cool. So... it looks like it finished resolving. No issues. Great. Now we want to go to Assets, Play Services Resolver, Android Resolver, Resolve. I think that it just ran automatically. Yeah, that was the next step in the instructions for getting started. It actually says to go to Assets and resolve client jars. I think that needs updating. But the next step is to go into Google Mobile Ads here and put in our app ID. And the way we get our app ID is we go to our AdMob website. So we go https://apps.admob.com, and it'll take you to home. You log in, you make an account, you go to apps, add app, and when you click add app, it's going to say, have you published it? Yes or no? And you say no. And then it'll ask you for your app information and whether it's on Android or iOS. I've already set it up, but it won't let you delete it once you make it. So if I go to my apps and I say view all apps, you can see all my apps here. or I can just go to Crazy Tilt, which is what I've called this one. And now if you need the app ID, we need to go to App Settings, get an App ID here, copy to clipboard, go back into Unity, go to Assets, Google Mobile Ads Settings, enable Google AdMob, and paste in the Android slot. Okay. Now that that's done, let's go back to the Get Started page. So we are just using AdMob, but if you have an ad manager that's kind of delegating between multiple services, AdMob and Unity Ads, for instance, you would check that instead of just AdMob. And now we have to initialize mobile ads by calling mobile ads.initialize. Okay, so it gives you a little example here. And then we've got our ads. So when we make actual IDs for our advertisements, this is how we would do it. We go implement a banner, cool, and then just completely get it started. We'd go to create a banner view, we'd get our ad unit ID. Our ad unit ID is actually going to be in our AdMob page. If we go to add units and we say get started, you go to banner, then we'll say let's see, menu banner is what we're going to call it, create ad unit, cool, and then you get your ID right here. Don't worry, you can come back and get this. So we'll create another ad unit because we are going to have an interstitial ad. Select this and say interstitial, or say level ad. That's what we're going to call it, level ad, and then that gives you a public ID. Create another unit, rewarded ad, and we'll call it rewarded, and your reward amount, I'm just going to say 200 or 2,000, and our reward item is going to be, oh no, times, we actually don't need to grab this amount, it doesn't really matter, but I just put in a random number anyway. But reward item is just going to be x2, and then create ad unit, and then we get our ID. Cool. So we're done. We have our ad units. We have our IDs that we can copy. But before we put these ads into the game, we need to go and open the test ads. You can see how this gets tedious. You go and open test ads, go to the getting started page we were on before. Right under getting started, there's test ads. You click that and open it in a new window. It will give you your Android and your iOS sample ad IDs. So let's do this. These are all of our ad IDs. Let's create a simple script. We've created our placements, but we do need to kind of initialize our ads. So let's create an empty. We'll call it ad manager. Create another component called ad manager. This is just going to be a new script. Open it in Visual Studio. And we're just going to create a simple switch. Well, first we need to make this persistent. So I'm going to go get our template for persistent singletons, our global singletons. I have to look at this every time. I've got it. Okay, cool. So we make an instance. We make a region, and region, cool, and we'll call it instance. This is what's going to allow us to access this everywhere. Private, static, add manager. If you already have an ad manager, obviously don't name this ad manager, like this whole class, don't name it ad manager. I was just thinking about that. But we're just working with AdMob, and this is managing our ads, so I went with it. So we'll have a static instance. It's initialized as null. And we'll say public static ad manager instance bracket get if our static instance is null, then our instance equals find object of type of, and we'll pass it the class name add manager as add manager. Okay, and then return static instance. Now we'll do void on application quit. So when the application exits, our static instance should equal null. So it clears it out in memory. Cool. That is done. Now we can access Ad Manager anywhere. Now on awake, we want to set a few variables. Let's delete these little prompts here because they kind of get in the way. And we don't need update for this. Okay, so at the top, let's do, I believe it is a string, yeah, string banner, well, let's do bool use test IDs. It's going to be false by default, but we should make it, actually let's make it true by default. So we can just come back and check it later. Okay, so we've got use test IDs, then we'll have string banner test equals string banner live. Let's just call it banner ID. Then we'll do string interstitial test, string interstitial ID, string reward test, string reward ID. So on awake, we're always going to use reward ID, but if use test IDs is true, then we'll swap it. So banner ID is assigned the value of banner test. Then we'll do interstitial ID is assigned the value of interstitial test. And same for reward ID. Okay. So if we are using test IDs, use what is here. Alright, so without further ado, let's just go to our test ads page, copy our test banner, put it in banner test, and make sure you get rid of extra spaces and all that other crud that seems to copy sometimes. Alright, this is interstitial test. And rewarded test. And now we'll go get the live IDs from AdMob. Let's copy menu banner, put that as the default banner ID here, go back, copy our interstitial, put it as our default interstitial ID. We'll go back, copy our rewarded, and do the same thing. Okay, awesome. Now to initialize ads, let's check the guide because this gets really complicated. So enter getting started. We've checked AdMob, we've got our app ID. Initializing ads using Google Mobile Ads.api. In start, mobile ads, initialize status. Okay. Okay, sure thing. So let's do using Google Mobile Ads.api. Then we'll say mobile ads dot initialize, and we will give it, now that's, I'm having trouble understanding the path there, but let's just put our app ID, which we need to store anyway. Save it. I'm gonna go grab that app ID real quick. App overview. Oh, app settings. There we go. Okay, that's done. Now we initialize, and when I was calling initialize earlier, it says there's app ID and then there's system action, initialization status, init complete action. So that was the other thing you could feed it, is a system action. But I'm gonna feed it our app ID. Whoops. Just gonna call it app ID. Alright. Now we have it initialized, and the next thing we should do is go into the instructions for each one of these for implementing a banner and so on and so forth. We can also clean up our app ID because if you want to use Unity and iPhone, you can use this line. Let's implement this real quick. So at the beginning, we'll do a pound define for the compiler. We'll take our app ID. Let's actually take our whole app ID line, cut it, and replace it with their app ID line. And do the same here, only we're going to go back and do the same thing for Apple. So let's add app. No, we haven't published, but it's on iOS. I'm going to call it Crazy Tilt. Add it. And copy our app ID. You can do the same thing to our default banner IDs using, if Unity Android, that's our banner ID, interstitial ID, and so on and so forth. And just to tidy things up, test IDs. I'll cut the space out of that. And then the next part, in part 2.2, we're going to use these IDs to make our banners appear at the proper times. I'll see you guys in the next one. Hey guys, welcome to part 2.2 of creating a item collection game in Unity and implementing AdMob. So last time we got our IDs and we set up our placements for our ads, and then we also set up a Boolean flag to use test IDs, so we can swap these IDs when we need them, where we need them. One thing I am going to add is a don't destroy on load. And we'll say this.game object so that we can continue to call upon our ad manager instance when we go to other parts of our scene, like go into other scenes. So we're going to create, well, get a singleton reward-based video ad reference. And this is actually part of the documentation, but I'm subbing in our variable name reward ad. Reward ad is assigned the value of reward-based video ad dot instance with a capital I. And now we need to add a bunch of, let's say to do add event handlers. So we'll do that later. And now we're going to check to see if, well, before we do that, let's go and make some simple functions like void request. Let me scroll down so you guys can see. Request banner view, assign the value of new banner view. We're going to pass it banner ID, our ad size dot smart banner, our ad position. I'm going to put this one on the bottom. And then now we're going to test if we're using our test IDs. And if we are, our ad request is going to look a little different. So ad request is a new ad request dot builder dot add test device. Now what you want is you want to go find the code in your test ads. Like if you go to developers.google.com/admob/unity/test-ads, and you scroll down to the bottom, you have modified your code to call add test device. This is a different kind of builder. You literally just, actually I could just copy this, yeah. Control C, Control V, like this. Boom. So now you have your request for test ads. Now we're going to use this same device number throughout. So next we want to load the banner, which is banner view dot load ad, and we'll feed it the request. Alright, else, if we are not using test ads, then we'll create an empty ad request. Ad request equals new ad request dot builder parentheses dot build parentheses, and then we'll load the banner again. Load ad request. So we'll just feed the request into load ad for banner view. Okay, our next request function is going to be for interstitial ads. So void request interstitial, and we'll say interstitial is a new interstitial ad, feeding it our interstitial ID. Oh, I said that in a weird way. We'll pass it interstitial ID. Let me scroll down so you guys can see. And then from there, if we are, if we're using our test IDs, then this ad request is going to be the same as what we copied before, so just paste if it's still on your clipboard. Scroll down just a little so you can see. Then we say interstitial add dot load add request. Okay. Oh, sorry, interstitial with a lowercase I. That's what we called our add, interstitial. Then we say else add request equals new add request dot builder dot build. Sorry, builder parentheses dot build parentheses interstitial load add request. Load the request that we just got. Cool. Now let's add another one. Void request reward add. I'm going to say if use test IDs. You're starting to see a pattern here. Then our add request is going to be this. Reward add dot load add request, and then our reward ID that we loaded before. Else create an empty add request is a new add request dot builder dot build. Then we load our reward add. So reward add dot load add request, and then we say reward ID. That's where the ID gets fed into for the reward add specifically. So now we need a few more functions that are pretty simple. Let's do public void, there we go, show banner. If our banner view is not equal to null, then banner view dot show. Else debug dot log banner view is null. Oh no. Okay. Public void show interstitial. Just want to make sure I spelled that correctly. If this dot interstitial dot is loaded, interstitial dot show. Now public void show rewarded video add. If this dot reward add dot is loaded, reward add dot show. So this is checking to see if it's loaded and showing it if it is. We also need to add one more. I'm going to add this under show banner. Public void hide banner. Simple function. Banner view dot hide. Pretty straightforward. And now we're going to go get some callback functions. I'll show you exactly where to find those. Here it is. So we need a bunch of callback functions, but specifically for our rewarded ad. So we implement rewarded ads. Go down here. These are the functions we need, our add events. So in start, we need to add these add requests. Oh, also, if you haven't already, definitely put using system at the top, because we're going to need that. So under our to-do add event handlers, I'm going to paste these, and then I'm going to change our reward-based video to reward add. So I'm going to double-click reward add, Control C, then double-click these, and Control V, paste. All right, so now that we have those, let's scroll down. And these are our handlers right here. So you can copy this. Actually go down to the very bottom and paste them. And now that you have system, using system, it recognizes event args. I had an error when I was doing trial runs of this where this was throwing an error. Also, okay, so now that we've got this done, the next thing we need to do is implement our calls. So request banner should be called, let's see, kind of in the beginning. Let's say this dot, let's actually request all of them. Request reward ad, then we'll do request interstitial, and we'll do request banner at the very beginning. I'll say if scene manager dot get active scene. If you guys don't have scene manager in here yet, put using Unity Engine dot scene management up here in the included. Okay. Dot build index. We're just checking to see if we're at our menu build index. If so, show banner. Wonderful. We need to go into our game manager. On our level ended, add addManager.instance.showInterstitial. Under our go-to main function and game manager, add addManager.instance.showBanner. So when the level ends, it'll show an interstitial ad, and then it'll load the next level, which is great. When you run this, you will not be able to see the ads running in the editor. So it does not really matter if you've got your, how do I say it? It doesn't matter if you run it in the editor, it's not going to show your ads. It's not like Unity ads where it'll actually give you a test ad on the PC. You've got to be on your phone when you're doing this. So if you go to File, Build and Run while your phone is hooked up, then it'll run the game. It's been my experience that you do have to tap to kind of, like once the app is up, if you tap once on the screen, the banner will appear. I guess it kind of like focuses and refreshes. Let me see if I can show you guys. Oh, there we go. So we've got our crazy tilt. There's a banner on the bottom. Okay, yeah, that did load. That loaded perfectly fine. And then if I tap, let me see if I can coordinate this. If I tap ×2.
This is a rewarded video test ad. Nice job loading it. I'm going to go fire the reward
It
callback.
shows the test ad, and then it fires the reward callback. We haven't caught this yet. In order to catch that, we have to add something like a boolean to our, well, our ad manager isn't getting destroyed on load, and it's referenceable globally. So let's add a variable here, public bool x, let's say, yeah, x2 equals false. And then if it's true, we go into our collectible and say, this is where we update our score. We should say if addManager.instance.x2 GameManager.instance.score plus equals 100. So just add another 100 on top of that, and that's kind of like getting double during the match. And then one last thing we need to do on our level ended is we need to, in our load next level, when we go to main menu, actually, if we just call go to main, we should be able to fix this. So in our go to main, it'll load, and then we'll say addManager.instance.x2 is false, and we're going to set that flag back to false, so it will no longer apply the ×2 if you play again without watching a video ad. Finally, we need to go to our ad manager, go down to our event handlers at the bottom. There's a handle reward based video ad rewarded. That's going to work as expected. So once that happens, we're going to say ad manager.instance.x2 is true. And that's going to activate our ×2 bonus. So while I've still got this app loaded, I'm going to show you when we press play, nothing happens except, our game. Our game loads like we've programmed it. I'm going to play through a level. Okay, got the first gate, got the second one. Alright, now it loads an interstitial ad. This is an ad that shows between levels. You X out of it, cool. Now you're back in the game. Alright. One thing is it is showing the banner on my level 2, because in awake of our ad manager we have show banner. Now that's really strange that it would. You know what? I think it stayed in level 1 as well. I think we do need to call hide banner. That's one thing we did forget to do. So let's go to when we press play in game manager. Play pressed. Oh, ad manager instance hide banner. I already had that there. Interesting. Interesting. Let's call hide banner after play pressed, and just to be safe, let's call it after load next level. Okay, so I'm going to build and test. I think that'll just about wrap this video up, other than giving the player some feedback. Let's go ahead and do that real quick. That's not going to be hard. So this is our player prefab. Let's open the prefab. Let's add some particle system effect to it. Awesome. Duration of maybe 0.2. Lifetime of 0.5. Start size 0.2. Shape it's interesting. Sphere, and we can take our radius down, kind of match the size of our sphere there to radius of like 0.25. Now when I rotate the sphere, it should, come on now. Yeah, it rotates the particles with it. Let's make the particle system a little more interesting. Let's go to emission, maybe make it 100 particles. No, that's a little too intense for a phone or a tablet, so let's go to 20. Have velocity over lifetime. We're going to set orbital in the x direction of 5, y to 5, and z to 5. That's going to result in like this tangential cylinder. Never mind. That's not exactly what we need. Alright, what if it orbits along one plane? No. I thought I was onto something. Radial? Oh, okay. So that's how it's gonna fan out. Interesting. Just experimenting with this now. This is almost all we need. .2 and 0.6 for the size. or 0.2 and 0.1 for the size. That looks about right. Okay, we've got an effect on our ball. Let's hide this particle system. Let's go into our collectible script because that's on the ball. And we'll say, we'll give it a reference. Let's say game objects, PFX. Then we'll have void awake if addManager.instance.x2. If x2 is active, pfx.gameObject is set active true. Else pfx.gameObject set active false. Cool. That's all we have to do. Maybe. God, that particle system looks so boring. I really want to change it. Let's do color. No. Let's do start color. Random between two gradients. And we'll make one kind of this dark blue. And then we'll make the other a cyan color. Let's see. Restart the effect. Alright, cool. Gosh, that looks so much like everything else, though. I'm such a perfectionist. Okay. Let's go to yellow, and instead of blue, we'll go to like a magenta. Or, yeah, yellow and magenta. Sounds about right. Size over lifetime. I would like to... Yeah, we can keep it there. That works fine. And actually, if we go to our sphere, and we do need to make this a public variable, or serializable actually. Serialize field in brackets for particle effects. Now, when we click the editor a few times after we save, it should click the sphere again. Let me get there. We go. We've got a slot for our particle system. Apply it, and then we'll leave the player ball. Cool. So when I play, X2 shouldn't be active, so the ball looks normal. Great. That's exactly what I wanted. And now I'm going to build and run and test. That's validating the signing release and all this good stuff. When you guys go to release, of course, just go to your ad manager and set that Boolean to false for using test IDs. Okay, so let's see what's going on. Ad loads on the bottom. Good. Press ×2.
This is a rewarded video test ad.
And watch our rewarded video ad.
I'm gonna go fire the reward callback for you.
Okay. There's nothing you can see on the screen as feedback. You might want to add that. But when I press play, the ball actually has... Oh, it's actually going to be hard for you to see. But the ball does have sparkles around it. And it's kind of indicating that you're going to get double the score. So when I collect a cube, instead of getting 100 points, I get... or 200 points, I get 400 points. Then 800. Excellent. I'm going to test... Oh, there are no banner. There is no banner being displayed on this level right now. Interstitial ad is playing. Collecting... Okay, I am getting a banner ad on level 2. But regardless, that's how it works. I'm sure you can set to hide the banner as soon as level 2 loads or level 3 loads. And I think that actually is it. Just remember to go into your ad manager and set your use test IDs to false when you launch. That's going to wrap up this project. So I hope you guys enjoyed this. It was a lot of fun to work on. Please check out some of the other projects I've worked on, and I'll see you guys in the next one.